Welcome to Pre-Flight Press Briefing Day for Space Shuttle mission STS-117. You're looking live as Space Shuttle Atlantis heads to the launch pad at NASA's Kennedy Space Center in Florida for the final month of work in preparation for its assembly flight to the International Space Station in March. The 6-hour trip began at 8:19 this morning Eastern Time, and Atlantis should be at Launch Complex 39A about 2:30 p.m. Good morning from the Johnson Space Center in Houston. We have a series of briefings on the mission that begins with a shuttle and station status. That'll be followed by a mission overview, and then details of the 3 planned spacewalks, and then a press conference by the 6 astronauts that will perform the mission on orbit. First up, the program overview. To my right is Wayne Hale. He is the Space Shuttle Program Manager, and to his right is Mike Suffredini. He is the International Space Station Program Manager, and we'll hear from both gentlemen, and then we'll take questions. I'll turn it over to Wayne.
Thanks, Kyle. It's been my privilege over the last couple of weeks to journey around the major spaceflight centers of the agency and talk with the employees in a series of all-hands meetings. And I'd like to bring a few words from that here to you. We talked about what we did last year and what we're going to do the coming year, this year, 2007, and the future years as well. Last year, as you know, was an extremely busy year for us. We completed our return to flight activities and flew successfully 3 times in the Space Shuttle program. Next year, we're headed to fly 5 times. I should say 2007, the year we're currently in, we're headed to fly 5 times. But this is not a routine business. It's a very difficult business. It takes a large number of people paying an extreme amount of attention to detail to fly in space. Any space vehicle is a complex vehicle. We've watched colleagues in with other vehicles suffer setbacks in recent weeks. And it reminds us that what we're doing is dangerous business. It requires a lot of work, and we cannot ever take our eyes off the ball. So as we press forward this year with our planned missions, which are extremely ambitious, we have a tremendous amount of work that we're going to be doing for the International Space Station program. We must do it safely, we must do it professionally, and we must do it thoroughly. That's the message that I had with our workforce, and that's the message I'd leave with you today. This is not a routine business. It is certainly not for the Space Shuttle vehicle, which is a very complex and in some ways fragile vehicle, nor will it be easy or routine for the next generation of space vehicles either, although we certainly hope it will be safer and more forgiving. I have a manifesting chart I'd like to put up. In the program office, we don't always get to have the fun of dealing with the hardware every day, but we do talk a lot about schedule and budget. And I wanted to share with you a little bit about the schedule. This is our layout for the lifetime of the shuttle program off our Flight Assignment Working Group manifest, which is out there on our website for everybody to look at. And I'd just like to talk a little bit about what we've got planned coming up. As you saw, Atlantis is rolling out to the launch pad. We are a day late because we had a few little technical problems, as we typically seem to, but we believe we can make that up and still be ready to launch on March 15th. As you know, that is an advance on the date that we had originally penciled in. So much so, the team has decided to quit calling these no earlier than dates. They're now targeted launch dates because the program manager keeps asking them to consider moving them up. We were successful, as you know, getting the flight before Christmas in because we were able to accelerate by about a week. This flight coming up in March, as you know, has got a very large payload with the solar arrays on it going up to the space station. Following that, at the end of June, we'll be launching a logistics flight with the S5 truss spacer in there as well. STS-117 will do a large number of reconfigurations as well on the International Space Station. Later in the summer, the flight that had been scheduled for September 9th, September 7th, we are trying to accelerate that till the latter week of August. August 26th is our working date to take Node 2 to the International Space Station. We would like to make an attempt to launch that vehicle in lighted conditions. and that is the principal reason that we're thinking about accelerating that. This fall, we'll be carrying the European Space Agency Columbus module on Discovery when it returns to the fleet. We're putting a modification in Discovery, which Endeavour will have on its next flight, the Station to Shuttle Power Transfer System, SSPTS, which will allow us to use power on board the Space Shuttle from the International Space Station's large solar arrays and allow us to extend our time that we are docked. Currently, that mission on our manifest is showing up on October the 17th. That date is in negotiation, and we will fly when our space station partners are ready for us to fly. There's a lot of work to be done between the flight where the node arrives and the flight of the Columbus module. And then before Christmas, we hope, and currently scheduled for December the 8th, we have the first of 2 Japanese segments going up, which will be the Japanese laboratories, that followed by another flight about a year from now at the end of February. We'll get our international partners on board, and then you can see the layout for the remainder of the fleet with our Hubble servicing mission currently in early September, and more assembly flights into 2009, followed up by a series of logistics flights in calendar year 10. So we have quite a busy manifest. The last flight I would like to point out, we're showing July of 2010. My observation is that gives us plenty, well, I shouldn't say plenty, there's never plenty, but an adequate amount of margin should we run into some technical difficulties or schedule problems to complete this manifest before the end of fiscal year 2010. At the same time, with this reusable vehicle, we're trying to draw down our workforce, particularly toward 2009 and 2010. We will wind up manufacturing in some areas. It's interesting to note that it takes about 4 years to build an external tank at our factory down at Michoud. The last tank is in assembly at this time. And starting about the middle of this year, we're going to be turning over parts of that facility to the Constellation program because we will no longer need them for the Space Shuttle program. We are currently in the first large acreage sprays that we've done since before the Columbia accident. And so we are marching through that facility doing welds and foam sprays. At the same time, out at Canoga Park in California, where we make the Space Shuttle main engines, we're working up to having 15 engines in our inventory, and we are completing the last engine power head at that facility. And again, this summer we'll be looking at turning over parts of that facility to the Constellation program, where they will be working on J2 and other rocket engines for the Constellation program. So the Space Shuttle program is beginning to wind down in some ways. But we have a huge manifest ahead of us. As I noted to the folks in our all-hands meetings, we have more flights ahead of us than they actually flew in the entire Apollo program, so we are far from being done at this point. We certainly have a challenging time ahead of us for the next 3.5 years, but I believe that we are on a path because of the very hard work and attention of many thousands of people around the country to being successful in completing the International Space Station and setting it up for many years of active research and productive endeavors to help us on the way back to the moon and onto Mars. And with that, I'll hand it over to Mike Suffredini.
Well, good morning. As Wayne said, we have a very busy year this year, but significant to the international partners that are participating in the program. Also, Wayne mentioned we will complete the flights of the Columbus module and the GEM modules during the year that starts with this flight in March. And with that, we'll have all the partners finally on board with their modules, save for the external facility that the Japanese intend to fly, that we will fly about a year later. So I thought I'd spend a little time with you this morning talking about the tactical plan that will occur in the 1-year time frame, March to March, and show you how this all leads up to the flight of the GEM module next February, at the end of February next year. I won't spend a lot of time on the flight coming up, the one we're here to talk about a bit today, because Kelly and Kathy and Floyd will go through all the details in the next presentation. So I'll kind of set that one aside and just talk big picture. First, I'll back up to the EVAs that we just completed with Mike and Sonny, and of course Misha inside doing the IVA work. They completed the reconfiguration of the thermal control system. That is, we're able to complete the hookups to the cooling system so that the lab could be cooled by the central system. And with that, we deactivated the early ammonia system that worked flawlessly for us for about 6 years on orbit. We're very proud of the performance of that system, and we're going to kind of keep it in a dormant mode so we can protect the ORUs should we need them as spares later on. But that system has now been deactivated, both of its radiators retracted and cinched down, and the next step for P6, of course, is retracting the last solar array, which will occur during this next flight. So 13A brings up the starboard inboard power module. That power is necessary for us to bring on the rest of the partner elements. And with that flight, as I just mentioned, we also have what appears to be a daunting task, at least we think it is based on our last flight experience, of retracting the 2B solar array. We have looked at our experience during the previous flight, and we have looked at different techniques, and so you'll see, and Kelly will walk through that with you a little bit, that we're going to go through a process to try to slowly retract this array during the sequence of a couple EVAs, and so we'll have the crew available to help us as it is retracted, and see if we can't sneak it in without shaking the array quite so much like we did on the last flight. So that'll be our goal, is to do a little less agitation array as we retract it. Now with that gets us ready for the next flight. The next flight in the summertime is the 13A.1. That flight has a logistics module as well as a pallet full of spares. This pallet will be installed for the first time on an unpressurized capture device we have out on the trusses. This one will go on the port side. And this whole logistics pallet will be removed from the payload bay, and what is one of the major components on it is a CMG to replace our CMG-3 that has failed. We'll lift that whole thing up and put it on the truss. In addition to that, of course, we have a logistics module. This will be, because of how full the next few flights are, this is really our last flight for the shuttle in this year period of time, where we can get a dedicated logistics module. And so that's very important to us, since by the time we put all the crew supplies that are necessary for the shuttle crew in the mid-deck, we don't get quite as much supplies for the station crew. So that's critical to us for this next year, to get all those supplies transferred over. That leads us to, towards the end of the summer, the arrival of Node 2. Of course, that's a key element to installing the both the ESA and ESA's Columbus module and the JAXA GEM module. But also during that flight, and as important, is the move. We will now move P6, which at this point now has both of its arrays retracted and as I told you, the thermal system deactivated. So now we'll move P6 from its temporary location on the Z1 truss and put it in its permanent location, which is port side outboard, and then we will redeploy those arrays and reactivate that truss during that mission. And that finally puts us in a position where we've got the cooling system and the power system in a configuration to take on the extra loads of the new labs that will come on board, and that paves the way for the arrival of the Columbus and GEM modules. Now, what is important, and Wayne touched on a little bit, is there's quite a bit of work we have to do to reconfigure the space station for the installation of the node in its permanent location. When we come up on the flight in the summer, we actually installed the Node 2 on a temporary location on Node 1. And then after the shuttle leaves, we have to remove the docking port that the shuttle utilizes, we call it PMA2, and install it on Node 2. and then we grab the whole Node 2 and then stick it on the end of the space station. And then there's a number of configuration changes we have to make in terms of power and cable connections that we have to redo, and we have to then hook up the cooling system to Node 2, because all the cooling of those 2 modules to fly up have to be cooled through Node 2. So there's a series of 3 EVAs. Again, we plan to implement them the way we just did these last set of EVAs. We'll do them all in a row to save us airlock and suit configuration time and suit checkout time that's mandatory if we spend too much downtime between EVAs, in order to reduce the time necessary to do this reconfiguration. But it will be probably one of the most challenging sets of EVAs we'll do in the program, and while it's very well choreographed, it is also equally important to our ability then to turn around and fly these remaining modules that need Node 2 to get their cooling and their power from. So that'll pave the way for the launch of the Columbus module, which in and of itself is a fairly simple installation. It has a CBM interface that we've utilized a number of times, and so we'll install it and hook up its cables and activate it. It has a relatively short activation sequence, so it should be fully activated by the time the shuttle departs. And then after that, at the very end of December timeframe, we then start getting ourselves ready for the arrival of the GEM module. There's a pressurized logistics module that flies up on a flight we refer to as 1JA. It's STS-123. And then also in there, the Canadians are flying their last element, which was a special purpose dexterous manipulator, or the hand as we like to refer to it. It goes up on that flight as well and will be removed from the pallet and installed over on the ISS. And all of this then finally paves the way for a late February launch of the GEM module, which is the largest laboratory that will exist on the ISS. It'll be an awesome sight to see how it fills up the payload bay when it flies. It's also extremely heavy, and so very little will fly with the GEM module itself. And we'll install that and begin the series of activation events, which will take us into the stage for that module, because it's slightly more complicated. So I went through all that to try to give you a feel. We've had a very big year for the program. And Wayne talked to you about all the work that they have to do on the shuttle side, and equally on the station side, it's a little different for us because everything we do, every flight is a little different. And so we've spent many years preparing for this and training for this. The partner elements are ready to go fly. And what I thought I'd do is go ahead and go through a couple of things for you. One is a video of the sequence that we'll go through, and then we'll show you a video of the modules that are at the Cape that are ready to go fly just as soon as we're ready to take them. So with that, if we could start with the animation of the sequence of events that we will go through. On this video, the first thing you saw was the retract of the arrays, and that was already done during the EVA. This is the starboard power module that comes up on 13A, this next flight. And then also during that flight, we retract that array and its cooling radiator. 13A.1 brings up the little stubby S5 you saw there, and then this logistics module. And coming soon, there you go. Node 2 arrives, that's its temporary port, and then we move P6 outboard and redeploy its arrays. And that all will occur during the docked period. And then after the shuttle leaves, we move PMA2 there. We're going to install it on Node 2 as it shows. And then using the SSRMS, we will put Node 2 then on the forward part of the lab. Of course, that paves the way with all the reconfigurations that we have to do. And then we bring up the rest of the cooling system so we can take the extra load. So we deploy those radiators, install the Columbus module there. That's the SPITM with the logistics module that comes up first to go on the zenith port of Node 2. Then the GEM arrives, and we move the logistics module back to the zenith port of the GEM module. And that will be the configuration of the ISS after, in early March of next year. Okay, the next video I want to show you was it's a video showing you some of the hardware that's about to go fly. So you can just kind of see it's at the Cape and ready to fly, with the exception of the special purpose dexterous manipulator. It's still in Canada, but it's being loaded onto the pallet as we speak, and it should be arriving in the summer of this year. So if we could have that video up, I'd Appreciate it. This is the canister with the S34 truss. It actually went into the payload ground handling mechanism, the PIGM, yesterday. It actually got transferred, and so it's out at the pad waiting for the arrival of the orbiter, and we intend to install that, I think Monday is the current plan. This is a wide view of the SSPF. That is node 2. It is being closed out as we speak. Final testing and power-up testing are being completed this week. That's a picture of the European's Columbus module. It's going into its site back there. You can see it just barely back there. We have a couple pictures of what the SPIDM looks like, and it, like I said, will be arriving in the June timeframe. And this is the GEM module. You can see that it's a very large module. I'm waiting for its ride as well. The GEM is pretty much closed out, ready for flight. They're doing some minor things. I think we have still yet to load the water for the cooling system, but other than that, it's pretty much ready to fly as well. The final thing I'd like to show you is just a quick picture. It sort of shows you all the different vehicles that want to go fly. As you look at this, it's not important to get fixated on the dates, but we're being kind of joking in the program. We just went through the list of the 6 shuttle flights that have to occur. Well, during this period of time as well, we have 4 Progresses that are going to fly to station. We have 2 Soyuzes that will exchange crews, and we have the first flight of the autonomous transfer vehicle, the European vehicle that's going to fly to ISS. In addition to that, we have the number of EVAs that we've talked about in order to do these configurations, many of them during docked operations. We generally do 3 or 4 during docked operations. And of course, I've told you just about the 3 we've just performed in this particular stage and the ones we'll do after 10A. So we have a very busy program to implement this year. We've spent the better part of the last year preparing for this, also trying to figure out, you heard Wayne say we're negotiating the date for the launch of the shuttle. Well, you can just see from that picture why we're negotiating the date, because there's a lot of other vehicles trying to get to and from station, all of them with their own requirements, going to different ports, but there are some conflicts between different vehicles and when they get there, when they leave, and the preps we have to do for that. So just the very act of getting all of that choreographed in any one year is not an insignificant effort. Let's see, the last thing I'll leave you with is at the end of January we had a heads of agency meeting where the heads of ESA and JAXA, the RSA, NASA, and the Canadian Space Agency got together. Strategically at that meeting we reaffirmed our commitment to expand the ISS to a 6-person crew in 2009. We've confirmed that hardware is either developed or in development on schedule to meet those dates, and we just recently completed an agreement with our Russian counterparts to increase the Soyuz transfer capability in order to allow us to transfer 6 crew to and from ISS and have the rescue vehicles necessary for that. So this is a very big year for the program. This flight, of course, is a significant step in that year, and we're looking forward to it. Thank you very much.
Okay, thanks, gentlemen. We're ready for questions as usual. State your name and affiliation for the audience out there. We'll start with Gina.
Gina Sinceri, ABC News for Wayne Hale. Is there any sadness building the last external tank and transitioning to Constellation, or you're going, whew?
Well, you know, that's a very good question, because it is a mixed emotion feeling, because the Space Shuttle is such an incredibly capable vehicle, and so many of us have spent so many years working on the Space Shuttle as a launch vehicle and a platform to do EVA and assembly and all these other things that we can do, service the Hubble Space Telescope, for example. And so we're all going to be very sad when we retire it. But at the same time, there are certain things about the Space Shuttle that, you know, we just can't make better. And we want to have a safer and more economical way to get people to orbit, and in fact have the capability to go on with the exploration of the solar system. And that's what the Constellation program, Orion, and its launch vehicle Ares are going to do for us. So that's very exciting. We're going on to the next step. It's a little bit like taking your old car that you really have enjoyed and have a lot of fond memories of, and taking it, trading it in on a new one, which is, you know, going to have some new bells and whistles and new capabilities. So it's a mixed feeling.
Tracy.
Thank you. Tracy Watson, USA Today for Wayne Hale. As you look at this very crowded upcoming flight schedule, I'm wondering if you are concerned at all about schedule pressure growing and undoing some of the gains that you have built up in the last few years.
Well, clearly, you know, having a schedule helps us organize our work, but we've got to be vigilant to make sure that we don't allow ourselves to be driven by the schedule. We're flying these flights in the order that we can, as rapidly as it is reasonably possible to do it, but we fully intend to keep all of our safety practices in place. So I would expect from time to time we'll see little things that may impact the schedule. As a matter of fact, we had one of those, you know, we're rolling out a day later today, a very small example of that because we had some technical problems that we need to have fixed. We've got some work we're doing out at the launch pad, which is going to use several of our pre-planned in contingency days, and then if we don't launch on the 15th, if we launch on the 16th or the 18th or the 20th, because we've got some work that we need to do, then so be it. We cannot let schedule drive us to do something done. At the same time, we really would like to get all these flights done by the time that the President and Congress have told us to retire this set of vehicles. So we're struggling a little bit to maintain the proper tension, and that's going to be with us to the end of the program.
Just to follow up then, if I might, how important is it to get all those flights that are scheduled for this year done by the end of '07? How, and maybe this is for both of you, how big pain would it be if one of them falls into early '08?
It would be some readjustment to this fairly complicated traffic model that's going on at the International Space Station. I'll let Mike tell you his answer, but the bottom line is it is not a big deal or a huge disaster if one of the flights slips out of calendar year '07 into calendar year '08. As a matter of fact, you know, I probably shouldn't give odds. You know, it's not outside the realm of possibility at all, and we will accommodate and adjust to that if we need to. Mike?
Yeah, that's true, Tracy. I mean, we have a number of vehicles that try to fly to ISS, as I showed you, and they all have the same things. Things come up, and you miss your date, and so we have to rearrange. Sometimes movement's easy, sometimes it's difficult, but we will always plan to move ourselves around in order so that the launch vehicle, in this case the shuttle, is ready to fly safely. And so there is, it's from our perspective, moving to '08, it's not a huge deal to the program. It's work, but it's we can wait for the modules to arrive a little bit later if that's necessary.
Mark.
Mark Crow, Houston Chronicle. Have a couple of questions for Wayne Hale. How many people do you count working on shuttle program now, civil servant and contractor?
That's a good question, Mark. We try to keep tabs of this, and of course we have a lot of people that work on multiple programs, and they spend part of their, I'm sorry, there's some. Okay, let me start over again. There are a lot of people that work at NASA or for the contractors that work on multiple programs, and they charge time accordingly. So we talk in equivalent people, if you think about it that way. We have around the civil service of the agency, we have about 2,800 or so civil servants that we count as working on the Space Shuttle program, and we have about 14,000 prime or major contractors working on the Space Shuttle program. You know, we have ATK out in Utah. We have the United Space Alliance, which does all the assembly ops down in Florida, as well as mission control, much of mission control here in Houston. We have the Boeing Corporation supports us with engineering support. And Lockheed Martin builds the external tanks down at Michoud. So those We have about 14,000 people involved in that. And of course, there are a lot of sub-tier suppliers and support contractors that I'm not counting in those numbers, but that's roughly the number that we quote, between 16 and 17,000 civil servants and prime contractors work on the shuttle program.
You made some remarks at the beginning of your briefing about focus, and I'm wondering if you can explain whether you reached out last week after an astronaut arrest to the shuttle workforce, how you did that, and what you told them, and whether you consider that a distraction or not.
I don't think it's a distraction, and we did not do anything particular from the program office. I think that was handled by Johnson Space Center and the appropriate folks.
Bill.
Bill Harwood, CBS, with a couple for each of you. For Wayne, you mentioned lighting for the Node 2 P6 relocate flight. Is that something different on that flight, is why you want lighting versus some other flight that you can launch at night? Can you give me a quick update? I'm assuming that December flight with Euro, you guys will fly over, and are there any restrictions based on your analysis? And for Mike, maybe an ATV status. I know that's listed in the summertime. I keep hearing it might not fly this year. I was wondering where that stands. Thanks.
Okay, well, let me start with year-end rollover. We are doing quite a bit of work this year to demonstrate that we can fly across the end of the year. You know, the shuttle computers, when they were originally programmed, the basic operating system was built back in the 1970s. It was not envisioned that we would fly across the end of the year, so it didn't handle it very well. We've made some changes, or in the process, I should say, making some changes to the way the software works to make that fairly simple and easy. So if we need to, at the end of this year, calendar year, fly across the year end, we will be able to do that. We will have some restrictions on the ground software at the Kennedy Space Center in terms of the launch capability, which will restrict us probably from launching literally on New Year's Eve. So there's probably a day or so that we would not launch right at the end of the year. It would take a lot more software to fix the ground system, because it's a more complicated system. So I think we're well on our way to being able to do that. The lighting for STS-120 is interesting because if you think about it, the tank that we're flying is the concern there. ET number 120 was our original return-to-flight tank back in the spring of 2005, and of course we had a couple of problems with the pressurization system and the fuel cutoff sensors at the bottom of the tank, which we have had to rectify on all the tanks. But we took that particular tank, after it had been loaded twice with cryogenic propellant, we took it back to the factory in New Orleans at Michoud, and we looked very hard at the foam. That was a very revealing exercise. We learned more from that tank than probably any other test that we had done in the 2.5 years before, about how the foam reacts and how it might be damaged by flight or pre-flight loading. So we've got a lot of repair work to do on the foam. And some of the new design work that we're going to put in, you've heard us talk about the ice frost ramps that we are redesigning to significantly decrease the foam loss potential that they might have. We're going to use ET-120 as a pathfinder for some of those new techniques. So there is a desire, we have not made it a requirement, but there is a desire to get information from the performance of that tank, which makes it desirable to launch that in the daylight. Again, we don't have that as a requirement. We're thinking about whether or not to make it a requirement, but the last week in August we would have lighted conditions, and the team has responded well to the challenge to see if we could accelerate by about 2 weeks that flight production and get that flight off a little bit earlier before we run into dark conditions. If we do wind up flying in the dark, right now it's not a constraint. It's just we'd like to get the engineering data if it's reasonable.
Yeah, the ATV is still scheduled for, currently scheduled for a launch on July 25th. Back when we picked that date, we knew it was a challenging date for the team to get that vehicle ready. And they've made a lot of progress, but the schedule still's extremely tight. We are getting to the point where we need to make a decision whether or not we're going to make that particular window. There are a number of things that have to occur that either between ourselves or ESA they have to start investing in. The Ariane guys, of course, need to know here pretty soon if they're actually going to arrive in the May time frame. In Kourou, in addition to that, if this is going to slip into increment 16, for instance, we need to get the crew started training on their job relative to the arrival of the ATV. And so we have a program review for ATV here in early March, and at that meeting we'll assess where we're at and either decide to stay on that date because we think we have a good chance of making it, or move off that date. We have a number of windows, a couple of windows, I should say, in the fall time frame that we're looking at. You saw that very busy chart I showed you. That's a good example of how things move around. The ATV wants to stay on orbit, or we would like the ATV to stay on orbit for close to its 6-month time frame, because a lot of the prop we get from it is from the reboost that we do with the ATV itself. It doesn't transfer as much of the prop as it has on board, and so we like to utilize that prop up while it's docked, and that takes quite a bit of time. So in order to keep it on orbit a long period of time, you can imagine we have progresses that are also trying to share those spots, and so it becomes a significant juggling act. But we'll take a look at all that in early March and see if it's appropriate to move that flight or not. And of course, that's a big ESA decision as well, and so they'll be the prime drivers for whether we move or not.
Mark.
Hi, Mark Kirkman with Interspace News. This is for Wayne. I need to ask you to summarize where you stand on COPV. And my problem is that I don't know how to characterize this, because I'm hearing everything from you're flying blind to somebody was just trying to get a silver Snoopy out of this. And now I'm hearing talk that I guess some of the proposal is to offload Ohm's prop. And I was wondering, is that a performance hit or is that just a margin hit? Can you tell me where from your seat where you stand on this issue now?
Well, your question's very timely. We're getting a major briefing today at my program board on the composite overwrap pressure vessel. You know, we have a number of large bottles of pressurized gas on board the shuttle that are carried in lightweight containers. If you were to make these pressure bottles of metal, they would be very heavy, and the standard in the aircraft and space industry is to make the bottle shell out of metal and wrap it with composite, in our case Kevlar fibers, to make it stronger. There has been some recent research that indicates that over long periods of time at pressure, the fibers can deteriorate. This is a real concern for us because obviously some of our bottles are getting to be quite old and have got a lot of time at pressure. You certainly wouldn't want a 4-foot diameter helium bottle that's pressurized to about 4,000 psi to burst on you. That would be a bad thing. So we don't want to have that happen. We've done a number of tests recently. We took an older tank out of the fleet and took it out to the White Sands test facility and pumped it up until it did burst and measured all the parameters on that, and it performed very well. It exceeded the design requirements for burst, but there is a phenomenon which has been documented in the at least in the academic literature, that says these fibers can deteriorate over time. So what we are doing is taking some steps operationally to try to lower our pressure where we have margin to lower the pressures in the bottles to increase our safety factor. We are also going to continue to do more testing to try to better understand this. It's a serious problem, and it's one of a number of problems that I would call aging aircraft kinds of issues that we face with these vehicles. You know, these vehicles have been in service for upwards of 15 years and have a number of flights on them, and some of these bottles have quite a bit of time at pressure. So we're trying to understand exactly what the hazard is and how to accommodate it. One of the difficulties would be building new bottles because, of course, all these pressure vessels were specially made. A number of years ago, the vendors out of business, and we'd have to qualify a new source vendor to build new bottles. So we're trying to handle this operationally by decreasing pressures where we can. It is mostly a hazard on the ground because those pressure bottles are at their maximum pressure while we're sitting there in the pre-launch state. And as soon as we lift off and you start using the pressurant gas out of the bottles, the pressure goes down and the hazard abates. So we're trying to understand it better. I would characterize it as a serious but not a showstopper kind of a problem. And it certainly is not something that somebody's trumped up just to get attention. I mean, this is a non-trivial engineering problem. It's quite complex. So more to come. Performance, actually, we will be giving up some margins in some area. In other words, some reserves, I think, are being reduced, but we would not give up real performance at this point. Perhaps if we understand it more fully, we'll have to take other steps, but we have a larger test series that's going to go into effect this summer, where we're going to try to understand this phenomenon even more thoroughly. Some of the predictions that we get were much more conservative than the actual test results that we've seen. So there's still a discrepancy in understanding this phenomenon.
Kate.
Tobin with CNN for Wayne. Your chart indicated you have 16 flights total between now and the end of the program. Is it your intention to fly all of those? Are any of them contingency flights that are built into the schedule to accommodate tasks that might overflow from some of the previous missions? And if everything goes nominally, will you fly contingency flights and do something extra?
Well, adding a flight to those number of flights probably isn't in the mix because, as I said, we're building tanks. Tanks are the only thing we really throw away. And so we're building enough tanks, so we're going to have one, I think, spare article that we're taking through major component build in case we need it. So, but the plan is not to fly additional flights. We have 2 flights at the very end of the manifest that are logistics flights, and I'm going to let Mike Suffredini explain their importance. Our intention is to be prepared to fly all 16, but there is some discussion about those last 2, and Mike, I'll let you explain that because you can do it better than I can.
Well, we'll see. The last 2 logistics flights, as Wayne said, we refer to them as ULF-4 and ULF-5, are shown as contingency flights. The theory being that if it turns out that we don't need as many spare components on board, and it's looking like we have the lift capability and other systems such that we could maintain the right amount of spares on orbit, that we perhaps could not require those flights. Now, both the shuttle program, as Wayne said, and the ISS program have in their funding the necessary funds to fly those flights. And today we still require them based on what I know. But we will continue to assess that and show them as contingency flights until the point where we know for certain that we need them on orbit. The shuttle, as somebody asked earlier whether we'll miss the shuttle. Well, from an ISS perspective, we absolutely will miss the shuttle because of its lift capability. The throw weight of the shuttle can take up 2 very large pallets, and these flights will have these pallets on them full of external ORUs. And this tends to be the most difficult thing for other carriers to do. Pressurized volumes and smaller masses and pressurized volumes tend to be an easier thing for systems to be able to do. It's a little more complicated to carry large external ORUs up and then figure out how to transfer them over to ISS. And so that's not a robust capability shortly after shuttle retires in the 2010-2011 timeframe. So the shuttle being able to do that for us and put many spares on orbit so that we can utilize those spares until the next carrying capability is available to us in the 11-12 time frame is currently what our thought process is. So we'll see how our spares do. We'll see our mean time between failures turns out for us. If it looks like there's another system out there that could carry the ORUs based on what we think the mean time between failures will be, then we won't require those flights and we'll release them. If it doesn't turn out to be that case, then we will plan to fly them, and so that's what we will watch over the next year or so.
Let's go to the Kennedy Space Center in Florida for a couple of questions there, please.
Hi, this is Mike Schneider with the Associated Press. I had a question for Mike. Is this going to be an 11, 12, or 13-day mission, and what factors will determine the length of the mission? And then also, I was wondering what the back end of the launch window is, and how flexible do you think the Russians are going to be as far as their launch of the Soyuz in early April?
Those are good questions. The actual length of the mission is, Wayne, help me out here. Is it 11?
11.
Yeah, it's 11. We have 3 EVAs planned, and assuming we can get the extra days, there's some margin in the system. We maybe will get the extra days, and if we need the extra EVA and other things fall in, we have a contingency EVA in our hip pocket if we need it to do a 4th EVA. So that's the current plan. The launch window has what we refer to as flight day 3 opportunities early in the window, so the first 7 or 8 days, and then for the next few days, I think it's something like every other day is a flight day 3 rendezvous. We like flight day 3 rendezvous because it gives us more dock time with the shuttle. So we prefer that. As we get towards the end of the window, we do have the Soyuz that needs to come up, and there's some jockeying of other vehicles, and so we haven't approached our Russian counterparts about that. They tend to have a little more difficulty moving their flights. They have to pick their backup launch date and basically put that into their computer and test that all out before flights. So they generally have a contingency launch day a couple of days later. And I'm certain that we'll work closely with our Russian counterparts also to consider, if necessary, what we had planned on a previous, and in fact implemented on a previous flight on 12A, where the shuttle could still be docked and have the Soyuz launch, just assuming that the shuttle is planning to undock, of course, before the Soyuz gets there. So we'll work very closely to try to get as many launch opportunity days as possible. Eventually, we'll have to deconflict them, though. One way or the other, we'll either have to push the Soyuz to the right or let the shuttle hop on the other side of the Soyuz. But right now, I would tell you that the launch window we have for the shuttle leading up to the Soyuz should be plenty to get us off the ground, a major failure notwithstanding, and so we have a high degree of confidence that we'll be able to get this flight off before the Soyuz.
Let me just add just a little bit. I didn't want to mislead you. We have planned 11 days, but there is capability to extend the mission to 13. I think in a little bit, Kelly Beck, the lead flight director, is going to be in here, and she can give you all the details on that. Mission ops folks have worked out an extensive plan on how best to utilize the resources. It depends on which day we launch and where the cryogenics are and what day we rendezvous on, exactly how it will play out. But the desire, as always, is to do the maximum amount of work that we can with every shuttle mission while it's docked to the International Space Station. And Kelly and the folks will be able to give you all the details on the options.
Thank you. I had a question for Wayne also. I was just, 2 questions about the SRBs. I was just wondering if you could talk a little bit about the chamber pressure on the right SRB that caused the delay in the rollout. What exactly is the cause, and has that been resolved? And then I also had a question on insulation loss on the SRB from STS-117. Basically, what kind of loss did you have, and did it pose any risk to the orbiter, and what are you doing for the upcoming mission to try and mitigate that loss?
Good question. So we always have a number of interesting problems to work when we get ready to launch the shuttle. It is an experimental vehicle, and we do many unique things that nobody else does. We have unique hardware that nobody else uses in space flight, and one of the things that we have worked on in recent years is an upgrade to the pressure sensors on the solid rocket boosters. Every solid rocket booster, left and right, has 3 sensors that sense the pressure during the motor firing that's going on. It gets up to about 1,000 pounds per square inch of pressure and then bleeds down. And when the motor has basically expended all its fuel, then the chamber pressure gets down to about 50 pounds per square inch, about what you would carry in maybe not your car tires, but a truck tire, for example, would have that kind of pressure. At that point, the thrust is low enough coming out of the rocket that it's safe to separate those boosters. And the software looks at those chamber pressures, as I said, 3 on each side, to determine when the boosters should be separated. We have brought in an upgraded set of transducer pressure sensors that are helping to make them more reliable. Unfortunately, the indications are that one of those pressure reducers on the right booster shorted out a couple of days ago during some electrical tests. The indication are that it had a short in it. We have removed that pressure transducer. We're actually rolling out to the pad with a hole. I mean, there's a plug in the hole. We have not reinstalled a pressure transducer. We'll do that at the launch pad. That particular piece of electronic equipment is on its way to the vendor, which unfortunately is in Buffalo. I say unfortunately because transportation's a little tough right now to get it to the vendor, for them to take it apart and look to find out exactly what happened. You know, there's a couple of outcomes to this. One is we could say we found a new problem in this entire class of chamber pressure transducers, and we have a number of the old ones on hand. We could replace all 6 with old ones if we need to. We certainly have a number of the new ones on hand if we think that this is a problem that's unique to this pressure transducer. So I think we're prepared to handle it either way, and certainly between now and March 15th we can replace that particular sensor at will. You know, when you get into these electronic sensors, that's the kind of thing that you deal with. This is a kind of a run-of-the-mill problem for the shuttle program to deal with. We want them to work. Let's see, insulation off the booster. During the video review, you know, we installed those new video cameras on the boosters. During the review of that video, we saw that there was some insulation that came off the little separation rockets that caused the boosters to separate from the external tank, the shuttle stack, at about 2 minutes into flight. And there was a piece of insulation that keeps those little solid rocket motors, I say little, it's about the size of an office trash can. Their entire firing time is about 1.25 seconds. But they provide quite a bit of thrust to move those steel cases away from the stack. We did lose a little bit of insulation. It did in fact fly up and hit the underside of the shuttle on the tiles, and we think did some superficial, as a matter of fact we know because we did samples off those tiles, did some superficial damage to the tiles in the aft part of the orbiter. This was a surprise to us. We're going about 4 times the speed of sound. These little booster rockets are located some 30 feet lower aft, downwind, if you want to think about it, of the shuttle. And for a piece of insulation to come off sideways and travel upwards of 30 feet against a Mach 4 airstream is just a little surprising to most people. Clearly there's some things happening in that rarefied atmosphere that we need to understand better. What we have done is we have made some changes to the way that insulation is on those booster separation motors for this flight. That has been trimmed back in a way that we believe will either eliminate or greatly reduce the potential of having any of this insulation come off and fly in this peculiar way to strike the shuttle. This is just an example of the very complicated things that happen. And again, I wouldn't say this was a run-of-the-mill problem. This was a little bit more interesting than some of our run-of-the-mill problems, but it is a good sample of the kind of things that we deal with. Every flight there is something new that we seem to have to work on to make sure we understand how to fly safely.
John Kelly with Florida Today for Wayne. I was just wondering if you could talk a little bit philosophically, I guess, about the sort of aging aircraft issues that you're dealing with this vehicle. And you had a good example earlier with the pressure vessels. And maybe the way to ask this question is, would you deal with a problem like that differently if you were going to fly this vehicle 10 more years instead of 3?
Well, yeah, I think you would, John. If we had a longer life ahead of us, I think it would be very clear we would go out and work on qualifying a new vendor to build a new part that takes sometimes 2 years to do. go through a qualification program, and we'd build some more tanks. And in a program that was going to continue for 10 or more years, certainly you would not only want to do that, you would have to do that. Given that we are trying to draw down our workforce, and we have already, not just because the shuttle's retiring, but because we thought we had all the parts we need, we've terminated some vendor contracts. You know, it's not practical to do that here in 2007. We were just barely getting tanks in the door by the time that we're retiring the fleet. So we're trying to manage it operationally, and that's a technique we would have had to use in the short term if we were flying longer. So we're not doing anything different other than we don't have a long event horizon, and you don't go after long-term solutions. You know, there are a number of safety upgrades I would personally have liked to have seen come into the shuttle fleet if we were going to fly past 2010, but they just don't make sense if the engineering, test, and analysis and implementation take you either right up to 2010 or past it. Clearly, it would be a waste of the taxpayers' money to go after those things. So we have to use their judgment in what we do these days.
Okay, let's go to Washington, D.C., NASA headquarters for a question.
Thank you. This is Tarek Malik from Space. This is Tarek Malik from Space.com and Space News. I have one for Wayne and one for Mike. For Wayne, I'm curious how setting aside space at Canoga Park at Michoud for Constellation will factor into your retirement plan for the orbiters in terms of spare parts, which orbiter goes first, that type of thing. And then a follow from Mike.
Okay. If you're familiar with aircraft, you know that all aircraft transports, you know, commercial aircraft transports or military for that matter, go in for periodic heavy maintenance. They go back to depot level maintenance. That is the same sort of thing that we do for the space shuttle. We periodically take them into depot level maintenance where you can take the systems out to get down to the basic structure to see if there's corrosion going on. You can examine all the parts and make sure they're all working as they were designed to work. We have a process that puts our shuttles into what we call the OMDP, Orbiter Maintenance Down Period, every 3.5 or 4 years. As a matter of fact, Endeavour, which will be flying in June, is just completing that kind of maintenance period. It's been in total refurb, and it'll come back basically a new vehicle for us. Atlantis times out at the end of calendar year 2008. It's time to put Atlantis into that regularly scheduled maintenance period. That takes about a year to a year and a half to accomplish. So if we were to put Atlantis into that OMDP period starting at the start of 2009, it would be done and ready to fly just at the time that the program's ready to end. That doesn't make a lot of sense. So what we're going to do is not put Atlantis into an OMDP, at least it's the current plan, and all plans are subject to review if conditions change, but the current plan is to put Atlantis into a state where we keep the power on, we keep the purges on, so that piece parts, black boxes, and so forth will be kept healthy for use as spares. This will help us draw down our spares inventory, by the way, but Atlantis will not be in a flyable condition, and it won't be in a condition where we could very quickly get into a flyable condition because, as I said, it is about a 1.5 year process to go through this depot level maintenance. So it would not be a flyable vehicle. We'll keep it at the Kennedy Space Center. We'll keep it in a conditioned space, and as I said, probably power on and purges on, so that we can use the parts out of it. So we're not going to ship it off to a museum at the end of 2008, but it won't be in flyable condition.
Thank you. And then for Mike, I was wondering if you could put in perspective the March to March time frame in terms of ISS assembly for the entire process itself. I mean, is this pretty much the peak of activity that you're going to see? Does it taper off after March 2008? And does that go the same with the spacewalks that are planned, I guess the 2 dozen in the next year?
Well, let's see. This is a very big year for us. We still do have a couple of quote-unquote assembly flights left after that One is, of course, the installation of the starboard outboard power truss, which will have at this point yet to have been at orbit. It is at KSC ready to go fly. In addition to that, the GEM module has an external facility that attaches to the aft portion of the GEM pressurized module, and that has yet to fly as well. Now, in addition to those 2 assembly flights, we have a number of logistics flights, both pressurized. We have 3 MPLM flights, and unpressurized, we have 3 what we call ULF flights that have unpressurized logistics carriers on them. And then, of course, the final step in the assembly process is Node 3, which is at the end of the sequence. And so we do have some assembly left after this flight. I would tell you this is a pretty intense period for us as a program, and that the flights after that won't be quite as intense in terms of how many major assembly steps we're taking along the way, although we still have some significant steps left. So from a concentration standpoint, I would tell you this is probably one of the most challenging periods for us.
Okay, we're back here for time for some wrap-up questions. Let's start right here with Nancy in the front.
Nancy Holland, KHOU. Wayne, and I apologize if you've said this number before and it slipped through my brain, but you gave Mark the numbers of 3,000 civil servants and 14,000 major contractors. Can you just update me on what those numbers will become as this program phases out and Constellation phases in?
Okay. Well, you know, we don't make huge reductions in 07 or 08. We begin to draw down the workforce in significant ways in 09 and then very significantly in 2010, obviously, starting with the production folks, those folks that build tanks, those folks that cast the motor segments out in Utah. Those production people will be moving off the shuttle workforce and we believe onto the Constellation workforce, where they'll be doing work for the new program. I didn't bring those numbers with me, Nancy. We can certainly provide those to you, but there is a very detailed plan on workforce and how we will draw it down. But the major reductions happen out for the shuttle program in 9 and 10. Clearly, the workforce that is down at the Kennedy Space Center that is processing the vehicles stays busy till the very end. The folks that work in mission control and do the flight design and astronaut training are busy to the very end. The engineering workforce that helps us solve the kinds of problems that we run into on a regular basis and keeps this vehicle flying safely will remain strong to the very end. So it will be a rather precipitous drop-off in 2010 at the end of the program. But, you know, if you look at what Constellation plans to do, they will need that workforce to be successful. So it's not that people are being laid off or sent out the door. It's that they will be changing their work from working on the space shuttle to working on the Orion or the Ares.
Mark Urban, Interspace News again. I just want to follow up on the question that you were asked about the SRB transducer. You mentioned it was new. I didn't realize that it was new. Is this the same as the smart deucer that you tested in November, or is this something separate from that?
You're in fact correct. This is they call it the smart transducer. It's in many ways got some advanced features in it. We can get some more detailed information on that. But one of the things that we really like about it is it's easier to produce. And so this was a step forward. Sometimes when you take a step forward, you have to adjust a little bit when you find how it actually operates in the field. And it's possible that this is just a random thing, or it could be something that says we want to adjust how those little piece parts are made.
So you can just go back to the old deucer for this flight?
We have the opportunity to go back to the old transducers if we need to. And as I said, we'll make that decision when the failure analysis is complete at the vendor, hopefully in the next few days.
Bill.
Bill Harwood again for Wayne. Just to go back to the pressure vessel issue, could you give us a little bit of operational insight into what it means when you say we could be cutting into reserves at some point, how that plays out in ascent to abort regimes and things like that, just to understand what the issues are?
The principal pressure vessels we're talking about are the orbital maneuvering system helium bottles, and we've got a couple of those on each vehicle. They're 40-inch diameter spheres. Their rated pressure is up close to 4,000 psi. What we're trying to do is take a very careful look at how much helium pressurant gas is required to pressurize the propellant tanks and expel all the propellant that you need to carry. Less propellant you need to carry, the less helium you need to have to pressurize those tanks. So folks are looking very hard at the mission requirements and making sure that we have calculated exactly what we need to carry. There are some regular reserves that we will not cut into. There is a particular ascent performance enhancement that we do called ohms assist, where we fire the orbital maneuvering systems engines shortly after the solid rocket boosters separate, about 2.5 minutes into flight. We are looking at reducing that ohms assist. That has the practical impact of reducing the ascent performance margin to orbit, but only slightly. It wasn't a big gain. It's not going to be a big loss. So we're looking at that on a flight-by-flight basis to see if we can reduce that operation as well. So there's 3 or 4 different things that we're doing. We're talking very small decreases in our margins here. We're not talking opening up an abort gap or anything of that nature. These are very small things.
And Mark.
Mark Carreau from the Houston Chronicle. I have a question for each of you, and for Wayne, it's about the budget and the continuing resolution, which I think has made its way through both chambers. Do you guys have enough money for this year to do what you talked about doing at the beginning of this briefing?
Yes, I can say from the Space Shuttle program, absolutely. You know, to put it in simple terms, and I have to do budget in simple terms because I don't understand the complexities of it, but in simple terms, the continuing resolution said spend the same amount of money that you spent in the previous year, which works for us. And I think probably Mike, I'll let him speak as well. I think from what I understand, the real difficulty for the agency is the Constellation program, which is going to ramp up this year, does not get to. And that is an agency-level question or a Constellation program question that's more appropriate for other folks. But from the Shuttle program, yes, we have the amount of money that we need to operate safely. And by the way, I'm committed to not allowing ourselves to get to a position where we don't have enough money to operate safely. We won't operate if we don't have the requisite amount of money or other resources to operate this program safely, because it's not in the best interest of the nation to try to skimp and have an unfortunate result from that.
And for Mike Safradini, the CMG issue, I wish you could answer a few questions about whether you've found a failure, the cause of the failure on the first one a couple of years ago, and whether 3, if you had just 3, would allow you to build out the station to its completion. And if you could also talk about whether you plan to spare a CMG on the space station at some point, and if you did, would it be stored outside somehow, and how would you preserve it, or if it's inside, where would you put it, that kind of thing?
Okay, yes, I can certainly do that. CMG-1's failure, conclusive evidence of the failure, we were not able to cause, to determine. That is to say that we couldn't point to any one thing and say this caused the failure. We did find a number of things that prevented the axle, if you will, of the gyro that's supposed to be able to float back and forth a little bit. We found that there were a lot of indications that it wasn't able to do so, and that over time, perhaps the cause of the failure was when it got hung up on one side or the other, it put wrong forces on the bearings, which eventually caused the bearings to fail. So there was some evidence of that, of this inability to move. There were scuff marks in certain areas. So we've just recently agreed to a number of design changes, relatively minor design changes. There's a Belleville spring we'll flatten the edges on, and we'll change material a particular nut, and then the whole floating shaft area we're going to try to redesign. We're still deciding what to do, but we're going to try to ensure that it just has a little less friction between the housing and the inner sleeve that has to move back and forth on that housing. All those design mods will be finalized in the April timeframe, and then we will implement them on the buildup of CMG-1. And we are also building up the inner gimbal today for replacement on CMG-3 when it returns home. So those mods are planned, and like I said, the final determination in April will be on this last mod that I mentioned to you. There was one other mod as well where the housing, it is believed that the actual black housing that you see when you see a CMG actually put forces on the gimbal and kind of warped it a little bit, and so we're off to make sure we can flatten the interface so that that doesn't occur as well. So we have a handle on all of the things that could have caused the problem, and we're off to make the design mods, and we'll implement those on CMG 3 when it returns. Let's see, the vehicle today is in probably, if I can use the term, the worst configuration from a momentum standpoint, how we sit today, and as soon as we put this power truss that comes up, we actually become a little more symmetrical, and it's a little easier from a momentum management standpoint. So today, the configuration is the highest stress on the system. The 3 CMGs can handle it. Of course, no CMGs can handle it because we have a prop system that can hold the attitude, but we prefer not to use the prop. So as we build out, it gets easier for the CMGs, and in fact, assembly complete, 2 CMGs will handle the stack fine. And so just to start with, you have margin in the system in that we intend to have 4 active CMGs and only 2 will be required. In addition to that, assuming we get these contingency flights and have the pallets on board, our intention is to have 2 spares on board, and they will reside outside. And this is one of those big things you mentioned. I can't fly CMGs inside. They're too big. Well, first of all, they'd be very difficult to mount. You'd have to mount them somehow, and then I can't get them back outside. So I have a number of very large ORUs like that, and that's the challenge in this program from a logistics standpoint after the shuttle retires. So the shuttle will bring up these very big pallets, which will lift out of the payload bay and stick on the station where they'll have power and data connections so we can maintain their temperature, and they'll be available for us when we need them. So we do intend to have 2 spare CMGs on orbit as well at the end of once the shuttle retires.
Okay, 2 more questions, Tracy, and 1 more at the Kennedy Space Center. Go ahead.
Thank you. Tracy Watson, USA Today, for Mr. Suffredini. The upcoming flight combines elements of 2 flights last year that were both kind of nerve-wracking in terms of what was going to be done on orbit. And I'm wondering, how, looking at 117 and then the other flights coming up this year, how do you rank them all in terms of complexity and difficulty of pulling everything off without a hitch?
Oh, Tracy, that's hard. One of the things I told you is every flight's a little different for us. But I will tell you that, and this will be an emotional answer, there's technical behind it, but when I use the CBM interface, which is how you attach pressurized modules, we've used it quite a bit, so I have some confidence in that interface, meaning that I've used it so often and I haven't ever experienced any failures that I'm a little more comfortable and not as worried that I might encounter a significant failure where I can't put the physical structure on board space station. When I can get major structures attached and I can get what we refer to as launch to activation power, so I can maintain the power on those elements, then I have a whole lot of time to go figure out how to solve the rest of my problems. So those pressurized modules, I'm a little more comfortable because I know the interface and we have a lot of experience with the interface. S34 fixing to fly is a mirror image of P34 that flew, and we were very fortunate. And so again, we have more experience. I feel pretty good about that. I'm nervous about retracting solar arrays. I don't think we've mastered the art of solar array retraction, and so I think that will be probably one of those things we will spend probably a little more time than we think we will today, but that time is available to us, and we know ultimately how to retract the array. It's just a matter of time. Deploying arrays, of course, I spent a lot of time telling you my concern about deploying arrays and the two that are going to fly. These have been retracted a little bit longer than the ones that flew on P3-4, so they'll probably have a little more stiction maybe than we saw P3-4, but we have a plan on how to deal with that. Our whole deploy scenario now assumes that we will have this stiction, and so we know how to deal with that. So I would tell you that I look at all the things we have to do, and I think we have experience in all those things that we have to do in front of us. Unlike previous flights, in some cases we had never done it before. So even all the way up to the retraction of the array, I feel pretty good that we know what we have some experience with the systems. Now, with all of that said, every one of these things we do, everything from just doing a bail on a pressurized ammonia line to an RTAS attachment of P6 when we move it outboard, all of them can have failures and that we would have to deal with. But I feel like in the list of things that we've done over the years, we have a pretty good understanding and experience with all the systems we plan to utilize, and so therefore I have some confidence. There is a lot of work, though, compressed in a very short period of time, so it's really going to be about the teams being ready with each one. And like Wayne said, we won't fly till we're ready, but I think because we've been planning all this for so long that the teams will be ready.
And one final question back at the Kennedy Space Center in Florida.
Hi, it's Mike Schneider with the Associated Press. I had a question for Wayne. You talked earlier about the need to maintain all the safety practices. So I wanted to ask you why the decision was made not to use the WB-57 planes during launch, which were able to capture, images of the launch.
I think we are using them. I'll go back and check. I'm going to have to go check on that one. I thought we were using them, so we'll find out.
Okay, that's all the time we have. The next briefing up will be much more detail on the STS-117 mission itself, so look forward to that at the bottom of the hour. And until then, enjoy the views of Atlantis as it continues its roll to the launch pad. Thanks a lot.